So you put 100 in, it bounces back, okay, with 33. So I still have 33 moving in the universe here. So if it was in a sealed container, you could understand. I have 100 going this way. Now I have 33 heading for this wall, and I have 133 heading for the other wall. And that's not a 100%, a 60% increase in the energy in the system? Of course it is. I mean, you could just ask the question, why is the reflection a minus? Okay, it's just as capable of hitting something. The one going to the left is just as capable of hitting a wall and breaking something. The other one going to the right is just as capable of, banging into the cat's tail and making the cat scream. How do you know which one you're supposed to minus?
All right, let's use the example of the enclosed box. We have the box, which is going to be the system. We have the two cards, the one mass and the two mass. This one is coming in with 100 momentum. It collides into the two mass, and this one will theoretically lift off with 133 momentum, and it will hit this side of the wall, so the right side, and then this one will reflect with minus 33 momentum to the left side of the wall. Once again, according to draft sign, this is free momentum because we have 133 hitting this wall and 33 hitting this wall, and the initial momentum was only 100, so we have 66 momentum. 66 free momentum. So that's impossible, right? Well, listen very carefully. So we have 133 hitting this wall, and then 33 hitting this wall, which means, so look, see, so the box moves. Let's say that the box is not attached to anything, that it is just freely on the ground, or I don't know, floating in space. And so if this card hits the wall, the box itself, the system itself will move into a direction. So that's the point. The box is the system. It will move after collision. When the cards hit the wall, it will move into a direction. So the thing is, it will collide into the wall with 133 momentum to this side. So it will push with 133 to the right, but at the same time, this card bounces back with 33 momentum to the left side. So the box will move with 133 to the right, but at the same time with 33 to the left. So what will happen is, of course, it cannot move at two directions at the same time. There will be a net momentum. It will only go, the system itself, the box, will only move into one direction. Well, which direction will it be after collision? Well, of course, this one has the most momentum, 133 this side to the right side and 33 to the left side. What will be the net momentum, and in which direction will it go? Well, obviously, it will go to the right because this one has the most momentum, 133 to this side. And with how much momentum? Well, the net momentum will be 133 minus 33, 100. It will go to the right. The system will move to the right with 100 momentum. Okay? That's why we have to subtract. So again, that's why we say minus 33. We give the minus sign. We use the minus sign for the left side. Well, you can choose. You can either say minus for the left side or minus for the right side, and the plus sign for the left side or the plus sign for the right side. I'm saying, for this case, I'm using the minus sign for the left side and the plus sign for the right side. So negative 33, pushing to the left side, positive 133, pushing to the right side, negative 33 plus positive 133 equals positive 100. So positive means to the right side, so it will move to the right side with 100 momentum. Do you not agree with this? Do you agree that there is going to be a net momentum for the system as a whole? Again, it's pushing with 133 to the right, but at the same time, this one is pushing with 33 to the left. So there's going to be a net momentum for the system as a whole. And since this one has way more momentum, it will obviously go to the right as a result. And with how much momentum? Yes, 100. But according to draft science, no, that's free momentum. So according to him, this one should only have 66.66. So if this one has 33.33, this one can only have 66.66, and that equals to 100. Because there can never be negative momentum, it's always positive, so this one has to be 66 and this one has to be 33. But then what will be the net momentum of the box itself? If this one has 66 momentum, it's pushing against this wall with 66. So the box is moving with 66, but at the same time it is moving to the left with 33. So what would be the net momentum? Well, it would go to the right, but only with 33. And so the initial momentum was 100, and now the system itself is only moving with 33. So we have somehow lost momentum. So that's the thing with your model. You say that we create free momentum. I say that you magically lose momentum. Where did the momentum go? Well, in fact, yeah, the conventional science doesn't produce free momentum. We had an initial momentum of 100, and the resulting net momentum of the system is also 100. Does it make sense? Are you going to accept it? Of course not. Of course not. But anyway, it's fun.